All right, guys, we're going to take a look at a couple of these discussion questions. So right now you should have this video split screened with Notability. And in Notability, open up your discussion questions, Unit 1 document. And as I go over these, remember you are welcome to add to or change or improve your answer. You just need to do so with red color ink right now. Please don't erase anything you did. If you want to change your answer or improve it, just use red. If you feel like as we go over it, you maybe didn't show enough work, you can go back and add work as well. If at any point you need to pause this video, you're welcome to do that as well. So let's look at number 2. It says, on a recent episode of Who Wants to Be a Billionaire, a contestant was asked to arrange the following 5 numbers in increasing order. How should she have arranged them? Well, the first thing we need to make sure we know is what we mean by increasing order. And so that means from least to greatest. So the smallest one first, and then they're going to get bigger as they go. That's what we mean by increasing order. So it wants to know how she should have arranged them. All right, well, I think the easiest thing is to first get them all into decimal form. You could also turn them all into fraction form. That's just going to be a little more difficult because you'll need to then get common denominators, and some of those will get pretty big. So we need them all in the same form. So the first thing I'm going to do is I'm going to change my 2 fractions into decimals. So 2/3, I can type into my calculator 2 divided by 3 if I need to. And what I see is that I get 0.6, and that 6 repeats. So it's 0.666666. At the end of your calculator screen, you may see a 7. That's just because your calculator is rounding it up at the end, but really that 6 repeats forever. And then if I type in 3 divided by 5 to my calculator, I see that I get 0.6 that terminates or ends. In other words, there's just 1 6. Okay, so as I look at these, and I'm trying to put them in order from least to greatest, sometimes it can get confusing because there's so many 6s here. And obviously we're in the decimal portion, so that can be sometimes a little different than if it's on the other side. So I personally like to get these all lined up and have the same amount of digits. So I'm going to take A first, and I'm going to write it, and I'm going to write just a whole bunch of 6s and then put ... to show that that keeps going. B, I'm going to write as 0.6666 because there's 4 6s there. And then I'm going to add zeros because remember after the decimal point I can add zeros and that doesn't change the value. For this one, I just have 1 6, so I'm going to add a lot of zeros there. So I'm trying to get the same number of digits in each one, get those all lined up. So D would be 0.666 and then some zeros. And E is the only one that has that 7 in there. It's 67000. So one misconception is that people can think that because E has less numbers, that it's smaller, but E is actually my biggest value or my greatest one because I'm looking essentially because they all start with 0 point, you can sort of ignore that. And so really I'm just trying to look here behind the decimal point and put those numbers in order from smallest to biggest or least to greatest. And so my smallest one is actually C, which is 3/5. Oh, I'm gonna get red there, it's easier to see. So 3/5 is actually your smallest one, or that's C. Then the next smallest one, all right, well, again, like really if it helps you, you could almost think about these like if you put a comma there, okay? So obviously 600,000 was the smallest. The next smallest would be 666,000, the one that only has 3 6s. So that's D, or in the original form that was 0.666. Then the next smallest would be the one that had 4 6s behind the decimal point. So that was B. And then the next one would be the fraction 2/3. That had 6 that goes on forever. That was A. And then the biggest one, even though A had 6s that go on forever, because E had 0.67, that one is bigger because that second place, the hundredths place there, is a 7 instead of a 6. So this would be 0.67 as my largest value. Again, one thing that can confuse people here is that even though here, if you're comparing 67 and 666, obviously 666 is bigger than 67, so this can sometimes confuse people. But when we're on the other side of the decimal point, again, because that 7 is in the hundredths place, and it's bigger than all these 6s or even 0s that are in the hundredths place, that's what makes E, or 0.67, the largest in my list. All right, so there's your answer there. If you need to pause the video right now to get this fixed and corrected, you can do so. And then we're going to go on to number 3. All right, number 3 says your class sponsors a benefit concert and prices the tickets at $8 each. Dale sells 12 tickets, Andy 16, Morgan 17, and Pat 13. Compute the total revenue, that means like the total profit, brought in by these 4 people. Notice that there are 2 ways to do the calculations. Can you show both ways? All right, so one way that you can do this is I can figure out how much Dale sold, which would be 8 times 12. I can figure out how much Andy sold, which would be 8 times his 16 tickets. I can figure out how much Morgan sold, which would be 8 times 17. And I can figure out how much Pat sold, which would be 8 times 13. And you're welcome to use a calculator here to make it go just a little faster. So Dale had $96 that he sold. Andy had $128. Morgan had $136. And Pat had 104. And so then if I add up all those totals, I see that together they made $464. So that's one way you could do it. The other way that I could do this is I could figure out the total amount of tickets that were sold. So that would be 12 plus 16 plus 17 plus 13. That's 58, and then I can multiply that 58 by the $8 for each ticket, and I also get $464. Does it matter which way you solve this? It doesn't. You can either add them all up and then multiply the 8, or you can multiply each part by 8 and then add them all up. Those of you who have learned about the distributive property before, which we're going to talk about in our next unit, this is the distributive property at work right here. The fact that you can add and then multiply, or multiply each part by the same number and then add, gives you the exact same answer. So make sure you have both ways shown here. All right, let's take a look at number 4. Now, number 4 was like a number trick problem. It told you to pick a number, and then it had you do several things to it. You added 4, you doubled it, which means multiply by 2, subtracted 6, and then divided it by 2. And it wanted you to do that with several numbers to see if you started to see a pattern. So I start with 1 just because that's easy. And then I did 2, and then I tried some bigger numbers, so I just did 10 and 50. Did you have to try the same numbers I did? No, of course not. But I would assume that you had to try it with at least 4 numbers. I also, before I say if there's a pattern or not, I also want to make sure I try it with negative numbers. So if you didn't try it with a negative number, let's try that together now. I'm going to pick -5. It doesn't matter what you pick. So -5, when I add 4, is -1. Times 2 is -2. Minus 6, keep change if you want, is -8. Divided by 2 is -4. So when I start with -5, I end up with -4. All right, so I boxed my starting number and my ending number. So when I started with 1, I ended with 2. When I started with 2, I ended with 3. When I started with 10, I ended with 11. When I started with 50, I ended with 51. And when I started with -5, I ended with -4. So is there a pattern? There is. Hopefully you see that the pattern is that the ending number is 1 greater than your original number. So the final number, I need to write what my pattern is 1 greater than my original number. And again, there's other ways you could say that. You could say add 1 to your original number to get your final number. But hopefully you see that it's always 1 greater no matter what number you pick. Now, I want to show you something pretty cool with this problem that you didn't already do. So you should write this down with me now. But this is going to help you on one of your future problems. I believe it is number 9. So make sure you write this down with me. We could also try doing this with a variable instead of a number. So instead of picking a number, I'm going to pick x. Well, the first thing I do is add 4. So that's x plus 4. Then I have to double it. Now here's where you have to be careful because I have to double all of it. In other words, I have to multiply the entire thing by 2, which means each part has to get multiplied by 2. So it would become 2x plus 8 because again, I need to multiply the x by 2 and the 4 by 2. The next thing I need to do is subtract 6. Well, again, I can't subtract 6 from 2x, but I can from 8. So this would end up with being 2x plus 2 because I do 8 minus 6. And then it says to divide the entire thing by 2. Well, that means each part gets divided by 2. So you could think about it this way if you wanted to. So 2x divided by 2 is just x, because again, 2 divided by 2 is 1, so that cancels. And then 2 divided by 2 is 1. So do you see how we end up with x plus 1? Now that's pretty cool, right? Because we talked about how it's always 1 more than what you started with. So in this one, I started with x, and I ended up with x plus 1. 1 more than what I started with. Again, if that's a little confusing to you, that's okay. We're going to keep practicing this. In fact, this is a lot of what we're going to look at in our next unit. But I just want you to see how this works with a variable and not only numbers. All right, so those are the only ones we're going to look at together. You should have, for your homework Wednesday night, tried 5, 6, 7, and 8, and then turn those 4 into Shobi. And then after you watch this video, I want you to do 9, 10, 11, and turn those into Shobi into that folder as well. So when you come to class on Monday, you should have completed number 1 through 11. Remember, on your first try, I'm just looking that you try it, that you show your work. That's a completion grade. Then you should be fixing them and correcting them as we go over them. So far we've gone over number 1 through 4, and we'll look at the rest of them next week when we come to class. Have a great weekend. See you guys soon.